Everyone's buzzing about data analytics, machine learning, AI, all that cool stuff, right? But how actually getting those awesome results? It's a lot like cooking. Imagine you're making an amazing dinner. You've got the best recipe, fancy tools, everything. But what if your ingredients are, like, totally not fresh? That milk's gone bad. Those greens look suspicious. Well, same goes for data. If the data you're feeding all that cool tech isn't any good, imagine the dinner you're actually cooking up. And suddenly, all that fancy, high-tech gear just becomes a really expensive paperweight. Alright, in this video, I'm going to talk about some common issues of data quality, focusing on accuracy, completeness, consistency, and validity. And stick around till the end, because I'll also show you some common tools we use to keep our data quality under control. First things first, let's talk about accuracy. There are a couple of things that can affect data accuracy, but the most common one is human error, or just manual mistakes. This usually happens in situations that require human interaction, like configuring files or uploading flat files like Excel or CSV, especially when there's no real-time data validation in place. Hardware issues can also seriously mess with your data quality. Faulty storage can scramble your files, broken sensors might feed in the wrong numbers, and network glitches can corrupt data while it's being transferred. The bottom line is, if your gear's not working properly, your data's not going to be reliable either. Signal interference can really mess things up. It distorts the zeros and ones in your data. So instead of clean information, you get bit errors. That means things like sensor readings or device IDs might come through completely wrong. Even if we use checksums to catch some mistakes, strong interference can still sneak past, corrupt the data, or cause packets to get thrown out. And when that happens, the accuracy of your data is seriously affected. Software bugs and logic issues are a big reason why data can go wrong. These problems can show up anywhere, in the device's firmware, the server software, or even the way data gets parsed. When that happens, you might see miscalculations, weird transformations, or data that's just flat out wrong. So things like sensor readings, IDs, or timestamps can all be off, making the data unreliable right from the start. While completeness, as another dimension of data quality, ensures that all expected data is present, meaning there are no missing records, files, or critical values necessary for analysis or operations. One of the most common completeness issues is missing data or logs. When expected data just doesn't show up, it creates gaps, like holes in the story you're trying to tell. Maybe a sensor failed to report, a device lost connection, or a log just never got saved. Whatever the reason, that missing info can throw off your whole analysis. Now, while delays usually mess with timeliness, they can also hurt completeness. If the data shows up too late, like after a report's already been generated or a processing cycle has passed, it might as well be missing. For that specific analysis, it's as if the data never existed. A 0-byte file is another sneaky issue that hits data completeness hard. The file's there, it exists, but it's totally empty. No records, no data, nothing. So whatever info that file was supposed to carry, gone. Your dataset ends up incomplete for that segment. What makes this problem even trickier is how hidden it can be. Sure, sometimes you can catch it just by checking the file size. But what if the log is normally tiny anyway? Or worse, what if that 0-byte file is tucked away inside a big compressed archive? You might not even notice it until you try to actually use the data. And by then, it's already caused issues. Data consistency is key to trustworthy insights. If your data isn't uniform across systems, it leads to confusion, bad analysis, and decisions you can't rely on. And today, with data pouring in from everywhere, keeping it all aligned and meaningful is more challenging and more important than ever. In IoT, metadata is constantly changing. New devices, firmware updates, gateway tweaks, it never stops. If you don't manage those changes, things go off the rails fast. You get misread data, missing fields, or conflicting results. And that totally wrecks the accuracy of your analytics, stuff like spotting RF issues, optimizing performance, or predicting failures. Now, version control helps a bit, but we need smarter ways to handle it. Think automated metadata tracking, schema registries, or self-describing payloads. The goal: keep everything in sync so your data stays reliable. no matter how fast things evolve. A schema is basically the blueprint for your data, laying out column names, data types, relationships, and rules. But when your actual data doesn't match that blueprint, like if a field changes or a new version sneaks in, it breaks consistency. Suddenly you've got mismatched types, dropped records, or data that just can't be parsed right. And that throws off your whole pipeline, making clean integration and analysis a nightmare. To stay on top of this, you can use tools like schema evolution, schema registries, and validation layers. These help your systems adapt to changes without breaking, so your data keeps flowing and your analytics stay on point. Data validity is a big deal when it comes to overall quality. It means your data follows the right rules and formats. But when that breaks, when the data is invalid, you get errors, bad analysis, and unstable systems. Basically, it becomes useless and untrustworthy. This hits especially hard in machine learning. A lot of invalid data issues are hidden. You might not even spot them at first. Sure, you can build algorithms to detect outliers, but noisy or messy data can throw off your models and wreck your feature engineering. In the end, you'll still have to spend a ton of time cleaning it up just to fit business rules or system constraints. Let's talk about business rules and data validity. These rules define what valid means in a specific business context, like what values are allowed, what formats are correct, and how different fields should relate. If data breaks those rules, it's invalid, plain and simple. The tricky part, automating those checks isn't easy. There are tons of rules, they can get super complex, and they're always changing. So turning them into code, keeping them up to date, and making sure they actually work takes a lot of effort, and sometimes a bit of detective work. People often separate uniqueness from data validity, but I think they belong together. A duplicate might be valid on its own, but it still messes up your analysis. And in IoT, duplicate data is super common, thanks to network retries, flaky connections, or buffering at the edge. That's why having an exactly once processing strategy is so important to keep your data clean and trustworthy. The good news: a lot of companies and communities are starting to take data quality seriously. They've built some awesome tools and ideas to help catch and fix issues early before they become real problems. Let me show you two that I use all the time. Data lineage is like a live map that shows your data's entire journey, where it came from, how it was transformed, and where it landed. It's super useful for debugging, tracking changes, and making sure everything stays reliable. So how is it actually built? There are a few ways. Some systems trace it at runtime by scanning the code as it runs, tapping into system logs, and hooking into processing engines like Spark or Flink. Others rely on metadata, parsing SQL, workflow configs, or pipeline definitions to build that picture. Some modern tools even combine both for deeper visibility. The result: when something breaks, you can pinpoint exactly where it went wrong. And if a change happens upstream, you can instantly see what downstream dashboards or reports it might affect. It's a game changer for managing data quality at scale. Data profiling is like giving your data set a checkup. It scans through everything, structure, content, and relationships, to build a quick but detailed summary. Think of it as the first step in managing data quality. You'll get stats like total rows, unique values, null percentages, min and max values, averages, and even patterns or outliers. It's super helpful for spotting issues early and creating smart, targeted data quality rules. Basically, it tells you what you're working with before you dive in. Last but not least, data quality matters at every layer: raw data, clean data, aggregated data, and especially in your MDM. I've got a table below that breaks it down by layer. Now, checking data quality across all those layers can feel overwhelming. And yeah, it can get expensive. But personally, I believe the raw data layer is the most critical. If you catch issues right at the source, you stop bad data from snowballing downstream, where it's way harder and costlier to fix. Start clean, stay clean. If you're enjoying this video, don't forget to give it a thumbs up and hit that subscribe button.